Data. Information collected to analyze, interpret, or make decisions. Data can take many forms, including numbers, text, or images, and it is used to identify patterns, draw conclusions, or solve problems. Example: a school collects students' test scores to assess overall performance and identify areas for improvement. Big data refers to datasets so large and complex that traditional methods of processing and analysis are insufficient. Big data often requires advanced tools, such as machine learning and cloud computing, to extract insights. It is characterized by 3 V's: volume, size, velocity, speed of generation, and variety, different formats. Example: social media platforms like Twitter analyze billions of posts daily to understand user behavior and target advertisements. Experimental data. Data gathered through experiments or controlled observations to test hypotheses or validate theories. This type of data is precise and collected in a structured manner. Example: a scientist measures plant growth under different light conditions to study the effect of light on photosynthesis. Digital technology encompasses tools and systems that process, store, or share digital information. It has transformed industries by enabling faster communication, data storage, and automation. Example: a smartphone allows users to browse the internet, communicate, and access apps, integrating various aspects of digital technology. Digital footprint. The trail of data left behind when engaging with online platforms. This can include search history, social media interactions, and online purchases. Digital footprints can be active, user-created, or passive, data collected without user awareness. Example: posting a photo on Instagram and enabling location services creates an active digital footprint, while websites tracking your browsing behavior create a passive one. Statistics. A mathematical discipline that involves collecting, analyzing, and presenting data to identify patterns and trends. Statistics help make informed decisions by interpreting data meaningfully. Example: a survey shows that 75% of people prefer electric cars, guiding manufacturers to invest more in eco-friendly vehicles. Algorithms. Step-by-step instructions or rules designed to solve problems or perform tasks. Algorithms are fundamental to computer programming and AI development. Example: a search engine uses an algorithm to rank web pages based on their relevance to the keywords entered by a user. Evidence-based. An approach that relies on verified data or research findings to support decisions or claims. It ensures reliability and validity in practices. Example: doctors prescribe treatments based on clinical trials that provide evidence of the treatment's effectiveness. Pseudoscience. Beliefs or practices that are claimed to be scientific but lack empirical evidence, scientific methodology, or reproducibility. These often rely on anecdotal evidence or assumptions. Example: astrology claims that the positions of celestial bodies affect personality traits, but it lacks scientific validation. Scientific models. Simplified representations of real-world phenomena used to explain or predict behavior. Models can be visual, mathematical, or computational. Example: the Bohr model of the atom visually represents electrons orbiting the nucleus, helping to understand atomic structure. Mean. The average value of a dataset, calculated by adding all numbers and dividing by the number of values. It represents the central tendency of the data. Example: if test scores are 85, 90, and 95, the mean is 85 plus 90 plus 95 divided by 3, which is equal 90. Median. The middle value of a dataset arranged in order. If there is an even number of values, the median is the average of the 2 middle values. Example: for the dataset 10, 15, 20, 25, 30, the median is 20. For 10, 15, 20, 25, the median is 15 plus 20 divided by 2, which is equal 17.5. Mode. The most frequently occurring value in a dataset. A dataset can have one mode, multiple modes, or none if all values are unique. Example, in 1, 2, 2, 3, 4, 4, 4, 5, the mode is 4 as it occurs the most. Trends. Observable patterns or directions in data over time or across variables. Trends help predict future behaviors or outcomes. Example, a rise in global average temperatures over decades indicates a trend of climate change. Diagrams. Visual tools for representing data, processes, or systems, making complex concepts easier to understand. Common types include pie charts, bar graphs, and flowcharts. Example, a line graph showing average monthly temperatures provides clear evidence of rising temperatures over time. Physical models. Tangible representations of objects or systems used for demonstration or testing. They help visualize and understand complex structures. Example, a 3D printed heart model allows medical students to study human anatomy more interactively. Simulations. Computer-generated or virtual representations of processes or systems that mimic real-world behavior. Simulations are used for experiments, predictions, or training without real-world risks. Example, flight simulators allow pilots to practice handling emergencies in a virtual environment. Formulas. Mathematical equations that describe relationships between variables used to solve problems or make calculations. Example, the formula for speed v = d divided by t, where v is speed, d is distance, and t is time, is used to calculate how fast an object is moving. Scientific theories. Comprehensive explanations of natural phenomena based on extensive evidence and repeated testing. Theories can predict new observations and are fundamental to understanding science. Example, the theory of evolution explains how species change over time through natural selection, supported by fossil evidence and genetic studies.